Hello everyone, this is a video to discuss the steps of the titration. Titration, in a nutshell, is when we make an experiment using an alkali and an acid. We put one of the reactants in a flask and the other in a burette. We let the liquid in the burette run until an indicator added in the flask changes color. In a nutshell, that's the operation. We use it to prepare salts of sodium, potassium, and ammonium and to compare concentrations, unknown concentrations of solution. Before we carry out, let us discuss what is concentration. Concentration means the amount of a solute dissolved in a solvent. For example, sugar and water. Sugar is the solute, water is the solvent. If I add a spoon of sugar and 20 spoons of sugar, the one with little amount of sugar dissolved is called dilute, while the one with large amount of sugar dissolved is called concentrated. So the dilute, little solute, a lot of solvent. Concentrated, a lot of solute dissolved in the solvent. So the experiment that we're carrying out today, we're going, for example, to compare the unknown concentration of two solutions of hydrochloric acid, solution A and solution B. We're going to use sodium hydroxide aqueous which of known concentration to do the titration. The first step is that we're going to put 25 centimeter cube of aqueous sodium hydroxide in the flask. Note that in everything that I'm going to be doing now, I want you to remember that what we put in the conical flask is the substance of known concentration. This is the one that I know everything about, which is the aqueous sodium hydroxide. We're going to use a pipette to add 25 centimeter cube of sodium hydroxide. We use a pipette because the volume is 25 centimeter cube. If it is less than 25 centimeter cube or more than 25 centimeter cube, we will not be able to use a pipette. Why? Because pipette measures a fixed volume of 25 centimeter cube. The second question that we might come across, sometimes he uses measuring cylinder. In that case, we improve accuracy by using a pipette because pipette is more accurate than measuring cylinder. The second step is that we're going to add drops of an indicator. For example, for the sake of our experiment, we're using methyl orange. The indicator will change color as soon as you put it in the sodium hydroxide because there is an alkali. Color of methyl orange in alkali is yellow. The color in this flask is the color of phenolphthalein when you put it in sodium hydroxide. So why do we use an indicator? The first question, to show the end point clearly. The end point is the point of neutralization. So we use an indicator to show the end point clearly as both reactants and products are colorless. We cannot and we never ever use universal indicator because universal indicator does not have a specific color. It has a range of colors, if you guys remember. This does not show the color change at the end point clearly. So we never use universal indicator. The ones we use can be methyl orange, which is red in acid, yellow in alkaline, orange in neutral. We can use litmus solution, which is red in acid, blue in alkali. We can use phenolphthalein, it is pink in alkali and colorless in acid, or thymolphthalein, which is also colorless in acid, but it is blue in alkali. But remember, never ever use universal indicator. It does not have a clear color change at end point. Third, we fill the burette to the 0.0 mark. I want to draw your attention that the 0.0 mark is at the top of the burette. So you open the tap and you drop whatever solution. The volume used will be where you stop, as we will see next. Sometimes, before we start the experiment, we open the tap and let the solution run. In this case, the acid solution run. We do that for two reasons. First, we want the level of the acid to be on the scale of the burette. But the second reason, which is just as important, is to prevent the presence of air bubbles in the tap of the burette. If we have air bubble in the tap of the burette, you need to fill the tap jet properly to prevent the presence of this air bubble. If the air bubble is present, the reading from the burette will be larger than expected because some of the liquid above it is used to fill the air bubble. So when asked, why do we let the acid run? To fill the tap jet properly, to prevent air bubbles. What will happen if we don't do that? The reading of the burette will be larger than expected. Now, when you're taking the reading, many make the mistake of going in this direction and say, this is 20, so this must be 20.8. No, we go in the direction from the small to big, not in that direction. Therefore, we're taking the reading from top to bottom. We take the reading from the lower meniscus, and the reading must always be in at least 1 decimal place. So in this way, the reading is 19 point, the decimal is 0.5. Okay? And if I want to calculate the volume used, I started my initial reading was 0.0. My final reading, which is after the indicator changed color, as we see, it became 19.5. The volume used will be 19.5, the final reading, minus the initial reading, which is 0.0. So the volume used will be 19.5. Do I have to write 0.0? Absolutely. I also want you to note that the color change is, initially I had in the flask sodium hydroxide. Methyl orange is yellow in sodium hydroxide. So the color change is from yellow to orange, and this is the end point. If I add more acid and I overshoot the end point, the reading will be larger and the color, the end point of the color will be red. It is the color of an indicator in an acid because the acid became in excess. Also, I want you to note the presence of this thing. This thing is called white tile. White tile is used to show the color change clearly. Okay? Last but not least, while you're adding the substance, in our case, it is the acid. While you're adding the acid to the flask, we swirl the flask like we are shaking the flask in in this direction, like this. Because the swirling is made to mix the reactants together. خلاص احنا we took the readings, we took the initial and final, and we calculated the volume used. I'm going to repeat the experiment again for solution B. I did the experiment with solution A. Now I want to do the experiment again for solution B. Before I do the experiment again, I need to wash the burette and the flask, the things that I used. The burette is washed twice. Once it is washed with water. Then it is washed with the solution I'm going to use, which is the acid solution B. The flask is washed with water only. I never ever wash with the solution or the substance I'm going to put in it. يعني in our case, we're going to wash the burette twice, once with water, once with solution B. We're going to wash the flask once only with water. And I will not wash with aqueous sodium hydroxide. Why do we wash with water? We wash with water to remove the remains of experiment 1. For example, the burette, I'm removing the remains of solution A. In the flask, I'm removing the remains of experiment 1 altogether. Now, I rinse the burette with the solution I'm going to use. In our case, I'm rinsing with solution B. Why? I wash it with solution B to remove the water. left from the washing, because water drops are going to be sticking to, they're going to be sticking to the burette like that. If I don't do that, if I do not wash with solution B, the solution will be diluted. When I add it, it will be diluted. I added more water. Like we said, I added more solvent, so it will be more diluted, which means that I will need more. The reading from the burette will be larger than expected. The solution became more diluted. While in the flask, I do not want to wash it with the solution. If I wash it with the solution, I don't need to. I already know that I am adding 25 centimeter cube. The amount added is known. I added 25 centimeter cube. I don't need to, I don't care if it is diluted. There is no such a thing as rate of reaction in titration. Whether it is diluted, whether you warm it, it doesn't make a difference because we know the volume and amount added. If I wash it, on the other hand, if I wash it with the sodium hydroxide, I added more particles. Let us imagine I washed the flask with sodium hydroxide. This means I added more sodium hydroxide in the flask. It will need more from the acid to be neutralized. Therefore, the reading from the burette will be larger than expected. Okay? Now we finished the experiment and we finished experiment 1 and experiment 2 and we saw the result. Solution A, from solution A, we needed 15 centimeter cube to neutralize the 25 centimeter cube of the alkyl. Solution B, we only needed 7.5 centimeter cube to neutralize the same volume of the alkyl. Remember that we know the concentration of the alkali, but we don't know the concentration of the solutions in the burette. This is my unknown. I don't know it. This is the unknown concentration. In experiment 1, acid A needed 15 centimeter cube. In experiment 2, acid B needed 7.5 centimeter cube only. This means what? Acid B is more concentrated. It has more particles dissolved. Because it has more particles dissolved, we only need a small amount for it to neutralize the alkali. So it is more concentrated. How many more times concentrated? How many more times concentrated? Compare the volumes. I needed half of solution B. Look at the volumes. Here I used 15 centimeter cube. Here I used 7.5 centimeter cube. I needed half the volume of solution B to neutralize the acid. So it is double the concentration. In a nutshell, just divide larger volume over smaller volume. It will give you 2. That's double the concentration. Okay? This works because we know that the concentration of the flask is known and the unknown is in the burette. When the unknown concentration is in the burette, less volume used is more concentrated. Again, when the solutions I'm comparing are in the burette, less is more. Less volume used is more concentrated. The opposite scenario, if I put the unknown in the flask, let us say this time I know the concentration of the acid, and I put the unknown concentration of the alkali in the flask. Alkali A needed 15 centimeter cube to be neutralized. Alkali B needed 7.5 centimeter cube only. This means alkali A has more particles. Because it has more particles, it needed more particles of acid to be neutralized. Unlike acid B has fewer amount of particles, so it needs less amount of acid. And that's my explanation, and that's my reasoning. Alkali A is more concentrated than alkali B. as more from the acid is needed to neutralize it. How many more times concentrated? Double the concentration. Why? Because we needed double the volume. So when we had the unknown concentration in the burette, less volume used is more concentrated. The opposite, when we have the unknown in the flask. When we have the unknown in the flask, more volume used is more concentrated. Okay? Think of it as both experiments are opposite. In one, the unknown in the burette, in the other unknown in the flask. Because they are opposite, we also have opposite result. Less is more when the unknown is in the burette. More is more when the unknown in the flask. In whatever way you want to rationalize it to yourself if you feel you might forget. I just want you to remember something, that if I am using the titration to prepare a salt, after the color change, the step I need to do is I'm going to repeat again using same volume of acid and alkali without an indicator. And then I do the crystallization. I cannot do the crystallization before this step. Also, if I want to increase reliability, I repeat and compare result. If I want to remove accuracy, we improve accuracy by repeating and taking average, because the average is more accurate. Like, for example, you will find in some questions that he repeats the titration to give you more than one reading. For example, 15.3 and then 15.0 and then 14.9 and then 14.85. And you want to calculate the average. I will ignore this one because it is far away from the others, and we call it not concordant. It is not within 0.2 centimeter cube. He will give you this input in the question, that concordant results must be within 0.2 from one another. And I'm going to add up the three readings, and then I will divide over 3. This way, I took the average, and the average is more accurate than any individual result. Sometimes he asks, why is the reading larger than expected? If this is the case, we say that this is because it overshoots the endpoint. Okay? Last but not least, in case we did not stress upon it before, pipette measures a fixed volume of 25 centimeter cube, guys. Don't forget that, while a burette can measure different volumes. Thank you and best of luck, inshallah, in your exams and your solving.